According to the International Energy Agency, heat accounted for almost half of total final energy consumption and 38% of energy-related CO2 emissions in 2022. This means decarbonising heat is a critical part of our energy transition. For industrials and large energy users, power to heat is proving to be a viable option to decarbonise, as well as providing opportunities to balance the electricity market. To learn more about power to heat technology and the costs and benefits involved in deploying these solutions, I spoke to Alex Robertson, CEO of ENERGYNEST. Alex paints a candid picture of the industrial heat consumption landscape and tells us more about the industries that are looking to make a change for a greener and more competitive future. I'm Pamela Largue, and this is the Energy Transitions Podcast. Alex, thank you so much for joining me today. We are talking about a really important topic, which is, of course, power to heat. But before we do, tell us a little bit about your background, because if I'm not mistaken, you are coming from a background in wind turbine manufacturing, specifically with Vestas in Taiwan. And of course, now you're working in the power to heat space. So that's quite a big change. Or would you say this is a natural progression for you?
Yeah, that's right, Pamela. I spent most of my career, over 15 years, in fact, at Vestas. And I decided to leave middle of last year. And I left without a plan. I just wanted to see, I'd had a fantastic time at Vestas. And I wanted to see what else was out there. And I'd expected I'd be sticking in offshore wind, which is where I was working at the back end of my career. But when I went out into the job market, there were all these storage opportunities banging on the door. And so, in answer to your question, is it a logical step to go from renewables and wind to energy storage and decarbonisation of heat? It's not a step I predicted, but now that I'm in that role, I really see the sense of it. And what I learned on the energy generation side in my career is I'm using it every day now that we're on the energy demand side.
Well, it makes sense because you need to have a really good and clear understanding of the renewable energy space and the fact that we really need flexible power. So having that understanding is obviously key and critical. So now let's drill down into the power to heat space, because it seems to be an increasingly popular topic that we're hearing more about, providing flexibility, the need for decarbonization. Explain the concept. Why is it becoming so popular?
Well, I'm pleased to hear that you think it's popular. I think it should be more popular. And the reason is that the space that we work in, which is power to heat, but specifically industrial heat consumption, it's an absolutely massive portion of our global emissions. It's in the temperature ranges. I saw a report that shows that in the temperature range of 100 to 500 degrees Celsius, industrial heat, we're looking at around about 29 exajoules of primary energy. Now, of course, you and all of your listeners will have an intuitive understanding of what an exajoule is, but for the few of them that don't, the total global consumption of cars, for example, is around about 50 exajoules of primary energy. So, if you think about how much focus and attention around the world there is to electrification of transport, which is great. It's fantastic to see the pace at which we are shifting to EVs. But if you compare, I don't think I'd say currently probably there's less, maybe 1% of that amount of attention faced on decarbonising industrial heat, but it's almost as big a sector. So I think this is the next big area where we can find carbon emissions that can be relatively cheaply abated.
Alex, why do you think it hasn't received the attention that it needed to? Why has there been that delay in perhaps industrials or government coming round?
It's a very good question, and I don't have a conclusive answer to that. I have some observations that I've made, and I can share them with you. But I'm still asking myself that question every day: is why is there not more focus on this? I think it's fair to say the focus is growing, and that's really positive, and particularly it's growing from industry. So the attitude I often see. So let me take a step back and explain what it is we're doing, and then I can come to answer your question. So you'd be surprised, or at least I was surprised to learn how much heat is used in almost all manufacturing processes. if you're doing anything that involves drying things, cooking things, applying things, drying, frying, and applying is our little one thing we say. Chemicals, pulp and paper, food and beverage. I mean, the list is endless. All of these factories are using heat, and they use a lot of heat. Like they use heat in the they have they have gas boilers in the tens of megawatts range, pumping normally steam into the factories for various different applications. Yeah, and this heat is coming from gas, almost entirely from gas. And gas, and I get it, gas is just great. Like gas is, it's, you can go and sign a gas contract with a gas supplier for 3 years, fixed price. You can get a massive connection to the gas grid, or multiple tens of megawatts gas connection to the grid. Gas is available in the middle of the day, in the middle of the night. There's no variation. It's just like super simple and straightforward. And I can see why the whole sector is just in love with gas. And so when I visit factories, so our customers are factories. They are factories consuming large amounts of natural gas to provide their heat for their industrial processes. And we visit them to discuss electrifying that gas, that heat supply. And we can talk a bit more later about how we do that technically and what other technical solutions are available on the market, because there's quite a range. But for many companies, the person that purchases the gas might be the same person that purchases, I don't know, the toilet roll or the food for the canteen. This is not considered a strategic part of their business. Their focus is on manufacturing whatever they manufacture, and gas is just an ingredient that they take. And what we increasingly see is that the more forward-looking companies are realizing that they are not just an energy consumer, they are a participant in the energy market. And that requires a shift in thinking from just passively buying gas at whatever the market price is to actually actively participating in the electricity market. But there's a big cultural shift required to do that. It's as I said a minute ago, the energy provision was a kind of, in most factories, is a very kind of unsexy, necessary evil next to what the real focus is on, which is on being really damn good at manufacturing whatever it is they manufacture. And I imagine this army of poor, undervalued energy people working in factories across the world who now need to be lifted into the centre's spotlight and have become actually crucial for the future competitiveness of these plants. And that's what we see. The forward-looking companies, they realize energy, and particularly heat, it might be as much as 40% of their production cost. They cannot afford to not be experts in producing, in how they procure their energy and how they decarbonize it. They cannot afford to just sit back and wait for other people to decide how we're going to get away from gas and switch to electrification, and then they'll just jump on the bandwagon at a later date. It's just too big a risk. This is 40% of their cost base. They know full well that at some point in the next 10 years, this is going to be switched to going to be electrified. And they're starting to say, maybe we want to start getting a bit of experiencing this on the front end of it in 10 years instead of at the back end when we're the last to join the party.
Alex, thank you so much for painting that picture for us. I love the drying, frying, and applying. I feel like I want to delve into that a little bit more, because of all the industries that you come in contact with and work with, the dryers, the fryers, the appliers, is there one particular industry that you think is really leading the charge in this, that are really taking the lead in terms of that mindset shift and implementing the technology?
I haven't identified one particular industry yet. What I can say is currently achieving a high level of electrification of heat comes with some cost premium, cost investment, and cost increase over gas, and we can dive into why that is. And also, what I alluded to earlier is it requires a lot of focus. It requires you to get new skills to learn new things about energy. And the companies that are really seriously progressing down that road are typically the companies that have a brand or interest in leading this decarbonisation transition. So that would be companies that yet have a brand, a known brand, a consumer brand, which they want to support by being able to say, my product was produced in a carbon neutral way or with reduced carbon footprint. That being said, so that's one group, is these companies that are, see a value in being a leader in decarbonisation. Then there's another group, which is the big energy consumers. So, and a good example of this would be pulp and paper, which have huge heat demand for drying out all the paper that they produce. And quite a few companies in this sector are realizing and have realized that they need to get a bit ahead of this curve and familiarize themselves and gain experience on the topic of electrification, even if they're not able to do it yet necessarily at a cost competitive level. It's definitely worth the investment to gather skill and gather experience in this whole field.
Hello, listeners. If you're enjoying the Energy Transitions podcast and you're interested in innovative energy projects endorsed by the European Commission, why not try Enlit's other podcast, EU Energy Projects Podcast? Give it a listen via enlit.world/podcasts or wherever you find your podcasts. Alex, you mentioned the focus, the skills, the knowledge that's required when you make a shift to this kind of power to heat technology solution. When you do take that step, what does the solution actually look like? What infrastructure, what technology is needed? And give us an idea. I mean, surely this is a costly business.
So I think the starting point to understand is that electricity is currently, at least, much more expensive than gas for providing heat, if you just simply turn electricity into heat and without doing anything clever in between. Now, why is that? It shouldn't surprise us, really, because the price of electricity is often determined by the marginal price of electricity is often determined by the cost of running gas peaker power plants. And we shouldn't, if you take gas and put it into a power plant, you have an efficiency loss and a cost of running that power plant, and then you transport that electricity from the power plant to the consumer. You have also another efficiency loss and another cost of doing that. The cost per unit of energy of electricity when it arrives at the door is never going to be able to match the cost of the gas, which you can just get directly. So you've got to do something smart to kind of get around this. And there's two main things you can do. You can use a heat pump, and a heat pump, essentially, for every 1 unit of energy you put in, you might get 3 units of energy out. So that's a good way of kind of fixing this electricity gas price difference. Now, heat pumps are good at the lower end of the temperature range, definitely up to 100 degrees, and in the direction in due course as the technology matures up to around about 150. But the higher you go temperature-wise, the harder it is to make heat pumps work effectively. Heat pumps on this industrial scale also require access to a lot of waste heat to step up from, so you need to consider that. But great technology, and definitely has a huge role to play in electrifying the lower end. So that's one way of doing it. You can try and multiply every unit of energy by 3. The other way of doing it is only use electricity when it's cheap. And that's our solution. So we're not really interested in the average price of electricity. We're interested in the cheapest 6 hours of electricity every day. And if you can only ever buy the cheapest 6 hours, you can bring down the cost of electricity much more in line with the cost of gas. Why is that? Well, the cheapest 6 hours are not determined typically by the cost of gas. They are determined by the marginal cost of renewables, and the marginal cost of renewables is more or less zero. So as long as there's a sufficient renewables penetration on the given grid that you're working in, you're going to get 6 hours of super cheap electricity a day. And we see that in all the areas that we work, is that there are these outlets of cheap or even negative electricity prices. And that's when we charge our battery. So now I should come on to the technical solution. So what do we do with these? How do we manage this? The ENERGYNEST, and there are other companies out there doing a similar thing. We do thermal storage. So our power to heat solution takes electricity from the grid at cheap hours and either converts it to heat and injects it directly into the customer's factory heat network, or stores it as heat in our thermal battery, and then at a later date, when electricity prices are high, injects that heat into the customer's thermal heat network. And this is it's just fantastic. I mean, it brings. There's just so many. I mean, I'm relatively new at this company, so I'm still kind of in the honeymoon phase of absolutely being completely intrigued and in love with the technology. But it's just got so many great benefits, and some of them are at a system level, and others are more benefits for the end user of the heat. But just to touch on it a bit, as we get more and more renewables on the grid, there will be more and more times where there is what you might call a surplus of electricity supply. Now, I'm reluctant to use the term surplus, because surplus kind of implies that there's nothing useful we can do with it. Well, there is something useful we can do with it, which is we can convert it into industrial heat. So these two worlds of an ever increasing amount of renewables on the grid and this flexible heat generation for industrial heat purposes, they just fit perfectly together. These are two completely complementary technologies, which is kind of like a nice kind of thing, circling back to my own personal career, coming from like the renewables side to now on the thermal storage side. So it's a really elegant and nice complementary technologies. And now the second point is, it is far cheaper and more efficient to store energy as heat rather than to store it in electrochemical batteries. And I think people can have an intuition for this. Our system, we generate the heat in what's called an e-heater, which is just a big resistor basically that converts electricity into heat. That heats up thermal oil, and the thermal oil is pumped through a special concrete block, and it heats up the concrete block. So the energy is being stored in hot concrete. You can imagine, hot concrete is not the most expensive material to manufacture. We use a special recipe of concrete, and it's a special low carbon formulation, lower CO2 impact than normal construction concrete, because it has a reduced amount of cement in it. But it's a pretty low cost storage medium. Certainly should be a lot cheaper than storing it in lithium-ion battery cells. Now, this works provided that the end product is heat. If we had to take electricity from the grid, convert it into heat, store it in our concrete blocks, and then convert it back into electricity and re-inject it to the grid, it would make no sense whatsoever. There'd be a massive efficiency loss, and you wouldn't bother with it. But as long as your end product is heat, then the right place in the value chain to store that energy is as heat and not as electricity in an electrochemical battery. And that's kind of the learning that I've had in these first few months at ENERGYNEST, is really appreciating the potential of these thermal batteries to more or less do most of what an electrochemical battery can do, but at a lower cost level.
The way you describe that, it really does seem intuitive. And I think it's a great segue into my next question, which is, do you think it's intuitive for the policymakers? Is this receiving the attention that it needs to from a policy perspective? Or do you think more can be done to really tap into the solution and all that it has to offer the industrial decarbonisation space?
I don't think it's at all intuitive to the policymakers that when we talk about electrifying industrial process heat, that what we're really talking about is balancing the electricity market and providing a massive storage opportunity. I think it's not intuitive. It wasn't intuitive to me when I started looking at the transition from Vestas to ENERGYNEST, so I wouldn't expect it to be intuitive to policymakers. But it is the truth, and that's the message we've got to get out there, is that what broadly comes under the umbrella of demand-side management has a huge role to play in balancing the intermittency of renewables. And the lowest hanging fruit on that tree is industrial process heat, because our battery and the other batteries like it, they turn a factory that says, I need 24/7 heat. That's my plant runs 24/7. I need constant heat demand. And I'm going to electrify that, but it decouples that heat demand from the electricity demand. And it turns what is a very unflexible thing, a paper mill that runs 24/7 at constant energy consumption, to suddenly a super flexible thing, which is a power to heat system which doesn't really care when it gets its 6 hours of heat. It can charge 6 hours of electricity. It can charge in the middle of the night. It can do a bit more charging in the day when the solar comes on. It can charge at any point. Who cares? And that decoupling, I think, isn't intuitive, but it isn't obvious, but it's definitely there, and that's what what our business model is based on.
Alex, I'm not familiar with power to heat technology in terms of how mature the technology is. It's not like solar, where it's obviously very mature and it's just a case of working on increasing efficiencies. What do you think we're going to see in the next 5 to 10 years in terms of power to heat solutions? Technology maturity, becoming more efficient, perhaps R&D and innovation?
So yeah, starting with the ENERGYNEST technology, our technology is very mature. It's a very simple technology. Our storage medium, as I mentioned before, is concrete. We use steel pipes. We use insulation. We use pumps. We use valves. Everything more or less off the shelf. So that's positive in that we really can enter large-scale decarbonisation of industrial heat without any delay. But it's negative because there will of course be cost optimizations that we will achieve with scale, but there's not going to be a step change in the technology of storing heat. It's really driven by the laws of physics, thermal capacity of concrete and so on. So I think that certainly our technology is very mature, and there's various competitors with differing levels of maturity. Where I think there is huge innovation potential is on how we deploy our technology and how we integrate it into our customers' factories. That getting this mindset shift in the world of manufacturing from energy as a necessary evil that I don't really want to spend too much time thinking about, but I expect it always to be there, to I am an active participant in the electricity market, and this is an opportunity for me to make money and for me to create value on balancing the grid. That shift and all of the innovative business models and applications of the power to heat technology that we develop, that there's loads of innovation there, and I think that will be what really drives the transition from gas to electrification, with of course some incremental improvements in the technology in the background as well. That's true for our sector. I mean, I'm certainly no expert in heat pumps, but I do believe there's quite a bit of innovation still to be done in that area. Heat pumps come from lower temperature ranges and are gradually pushing up into higher and higher temperature ranges, and I think there's quite a long technology maturity road and a lot of innovation potential there. And then at the higher end of the temperature range, where you get up in the 700, 1,000 degrees, there are a lot of technical problems there that have yet to be solved, and that's very much not ENERGYNEST's world, so I can't comment on that with authority. But there are high temperature industrial heat use cases that are not yet, where there is not yet a technically mature solution for decarbonising them or electrifying them, and that's where more speculative technologies like hydrogen and so on come into play. But the core of it, the bulk of this in this 100 to 400 degree kind of range, the technology is there today to address this, and this is by far not the most difficult and most expensive carbon reduction, carbon abatement opportunity that we face. This is really, we can really make some good headway here at limited cost.
Alex, I want to pivot back to something you mentioned earlier, and that's the fact that it's the forward-thinking companies that are really looking into these kinds of solutions. And something that's been on the radar in terms of the news lately is specifically around European competitiveness within the industrial space. Do you think solutions like this are critically important to ensuring a competitive future for Europe?
I think getting Europe to be a leader in electrification of all sectors is critically important for the future competitiveness of the continent. I was an early adopter or relative early adopter of electric cars, and I've always found that area fascinating, and I've always been amazed at how the degree to which the German government has protected the German manufacturers from really needing to do that much about electric cars, to the point that now my understanding is the German German car manufacturers are desperately playing catch up and trying to get more support from the government for electric cars. I think there is a tendency of industry not to want to change, and that government always wants to protect industry, and I get that. And it's about protecting jobs and competitiveness. But in so doing, I think poor government policy, which is done with the right intentions and is done based on the lobbying and requests of industry, actually results in those same industries losing their competitive advantage. And I think the electric cars, the story of European electric cars, is a good example of that. We didn't help our European manufacturers of cars by kind of not pushing them to go electric and providing incentives for them to go electric earlier. We've actually hindered them, and I think that will be the same here. So I really don't see it as, Europe needs to be a competitive place for manufacturing, but it also every company that consumes energy needs to busy themselves with the task of preparing and moving along the journey to electrification. If any policy that protects energy consuming companies in Europe from having to look at this and invest in this and spend time on this is not helping anybody. One of the things that, I'm based in Germany, and we just had the new coalition agreement for the German government between the CSU and SPD has been published, and it's largely, there's a lot of positive stuff in there for what we're trying to do. But one of them is that large industry that cannot make their energy demand flexible will be exempted from flexibility, from the need to make their demand flexible. Something I haven't paraphrased it exactly right. But I get where that's coming from. They don't want these big industries in Germany to suddenly become uncompetitive. And I'm sure those large industries are making a big lobby effort to make sure they're exempted from this stuff. But they are not helping those industries in the long run by insulating them from the reality. And the reality is that those companies that get smart and get experience on decarbonisation and electrification of their heat demand, they will be the companies that will succeed and will create a competitive advantage because of that. And those that put their hands on their ears and pretend it isn't happening will ultimately become irrelevant and fail.
Alex, I do have one final question for you. I feel like we've been on this journey with you through your career as you have been learning more about this technology and getting involved in the space, and of course with ENERGYNEST. Would you say that you're a bit of an evangelist? Because you are clearly very excited and very passionate about what you do. And I'm not sure that it's necessarily a honeymoon phase. It seems like you're very committed. What are your thoughts? Do you believe that you found your passion?
It slightly might undermine what I've been saying if we say that it's all just coming from my evangelism and passion. But there's certainly some degree of truth into that. And I can tell you that even today, after I've left Vestas, I still believe Vestas makes the best wind turbines on the market. So anyone who's interested, go knocking on their door. Yeah, I think what I'm particularly excited about right now is I've only been at ENERGYNEST a few months, but when I started, it felt, I was looking at the data, I was examining the customer business models, I was trying to get to grips with this whole topic of power to heat. And I have to say, there were days when I thought, my God, this isn't going to work. Gas is just so cheap and so easy, and electricity is so complex. And I would even say, and with all the levies and tariffs and taxes and everything on top, it can be so expensive that we can, no amount of innovation is going to close this gap. And those were the bad days. And I'm feeling, I have to say, much, much more optimistic as I've got more into this. And what's driving that is, the first point is, I think I was making a mistake when I first looked at this problem. And the mistake I was saying was, I'm going to switch 100% from gas to 100% electrification. And of course, that today looks like a daunting task, and it's hard to do that in a way that's remotely, in a way that you can get to remotely the same cost level as just using gas. But if we were to say, I'm going to switch the whole of electricity from conventional power stations, conventional thermal power stations to renewables, we would also you'd never move. You'd never even start on the first project because it's just too expensive, too difficult, too many questions. Where I've got to now is seeing that, well, we don't need to start at 100%. We can start at 30% or 50%. And that first 30%, getting from gas to electricity for the first 30%, that we can do. We can do that, I'm not going to promise that it's exactly the same cost as gas, but we are within range here of gas territory. And if there's a will, there's a way. We can make that work with creativity and innovation. And I think that percentage of how much we can electrify any given industry, any given factory, that is going to keep going up as we innovate. And it's 30, it'll be 50 in a few months or even a few years. It'll keep going up. Now, right now, if you ask me how do you get from 80 to 100 without having a big cost increase, I don't have the answer to that yet. But we will, ask me that again in 5 years' time, and I'm sure we will have the answer. So yeah, that's why I'm excited. Maybe this is, a message to anyone who's listening. If you or someone who works in a factory with a large consumption of industrial process heat, talk to us or talk to one of our competitors. There are ways to get started on that road to electrification without a massive cost impact, and certainly in a way that isn't going to damage the short-term competitiveness of your factory. Quite the opposite. If you start down this road, you'll be investing in equipping yourself for the future, and a lot of good things will come out of it.
Alex, well said. Thank you so much for sharing your wisdom and your candid insights. It has been an absolute pleasure to chat to you today.
Well, thanks a lot, Pamela, for having me on the podcast, and really look forward to seeing how things develop in our sector in the coming months and years. And hopefully we can talk again in a few years when we have some more good news and progress in decarbonising industrial process heat. Thank you.
Indeed. And thank you to our listeners for joining us. Until next time, goodbye. Thank you for listening to this episode of the Energy Transitions podcast, brought to you by Enlit and Friends. That's a wrap from me, Pamela Largue, and our producer, Kamo Motse. We hope you can join us next time. Visit enlit.world or subscribe for more episodes.